So Unit 3 is all about polynomials and polynomial functions. Today, what we're going to do is we're going to focus in on exponents and their properties and scientifical notation, okay, which most of you have seen all of that stuff before, just kind of remembering what to do and how to do. Okay? So, let's do this. I want you to remember the fact that x raised to the fourth power really means x times x times x times x. Okay? Okay? So, with that being said, I want you to try these 6. Come on now. These 6. Yeah, but okay. Make sure it was only 6. Try those 6 and simplify them, and then we'll talk about them in a minute. So I'm going to discuss the properties first that you see here. Then we'll come back and I'll show you the answers to these 6 properties. Okay? Right? So some of the properties that you should know in terms of exponents. The first one is called the product property. When you have the same base and then are multiplying that with the same base again, and you're dealing with exponents and such. Okay? So in this particular one, that would end up being a to the m plus n power, where you add the 2 exponents. Conversely, number 3 here, when you're dividing the same base with exponents, then you would subtract the exponents. Top minus bottom. Next one is power to a power property. And on that one, you multiply the exponents. Those are the 3 main, you'll use those a ton. The next step down is number 4 here. When you have a negative exponent, you make it positive by putting it on the opposite side. So like if it's on the top, because this would be technically like a to the negative m power over 1. So we move it to the bottom to make it positive. Likewise, if we have 1 over a to the negative n power, then that would be a to the positive n power. We would move it from the bottom to the top, and it would become positive. Okay? Or if you have a fraction that you're taking to a negative power, and taking the whole fraction to a negative power, if you just reciprocate the fraction, then that forces the exponent to become positive. Number 5, anything to the power of 0 is 1. Number 6 is kind of just an add-on to property number 2 from above, and that this exponent needs to go in. It's a power to a power there. It's also a power to a power there, but it is not a power to the power of the letter A. So A would stay the same because it's not being controlled. B would be m times r power now, and C would be to the nr power. Okay, so let's go back to the warm-up ones. Let's see what you remember problems. Okay, so this first one would be, I have the same base with both with exponents. I would add the exponents. That would be x to the 7th power for that one. Okay. Number 3, I'm dividing. I've got exponents. Okay, so I'm going to subtract them. 8 minus 3 would be to the 5th power. X to the 5th power. There. Power to a power here in number 5. I multiply them. That would be x to the 12th power. There. Okay. Number 2 will come down this column now. This is really going to be 2 to the 3rd power times x to the 2 times 3 power. So that means that this is going to be 8x to the 6th power. There. Number 4, this is going to be x to the 4 times 2 power. 3 squared, and then y squared, so that this would end up being x to the 8th power all over 9y squared. Number 6 is very much like number 3. Subtract them, okay? But because it would end up being x to the negative 5th power, if I subtract the exponent, I'm going to call that 1 over x to the 5th power. Because we, in higher level maths, love positive exponents. Don't like negative exponents. Because we lose the sign. Okay. Good times. Okay. So now let's try some of these on your own. Okay, so let's do, I think there's 2 on this slide, and I think there's 4 on the next one. So try these 2 on your own. So in this first one, we would have 2 cubed times x to the 3 times 3 power times y to the 2 times 3 power. So that's all told going to be 2 times 2 times 2 is 8, x to the 9th, y to the 6th power. Yes? Yes. Like it. Okay. Here on this one now we can go, this is x to the negative 3 minus negative 7 power. Negative 3 minus negative 7 is like negative 3 plus 7, which would be x to the 4th power. Okay. You could also there have made them positive exponents first by taking x to the negative 3 power and moving it to the bottom, then it becomes x to the positive 3 power. Taking x to the negative 7 power, moving it to the top, making it x to the 7th power, and then you can subtract 7 minus 3 gets you 4. Or you could simply just ask yourself, are there more x's on the top or more x's on the bottom? The answer in that case would have been there are 4 more x's on the top. Okay. Judging by the fist bump, I'm guessing that's how you guys did it.
Yeah.
And that's really fine. There is more than one way to do these problems. We're still using all of the properties, and as long as you use the properties correct, we should get the same answer in the end.
Okay.
And I'll be honest, I don't care how you do it, as long as you do it. You know what I mean?
Yeah.
Yeah. Try these 4. So on this first one, on number 3 here, I would take 2 times -3 because there's no exponents attached to either of those 2. So 2 times -3 would be -6. Then I would take x cubed times x squared. And x cubed times x squared, I'm going to add those exponents. 3 plus 2 is 5, so that's going to be x to the 5th power. And then lastly, I'm going to take the y's, y to the -4th times y to the -2nd. -4 plus -2 is -6, but I don't like y to the -6. So instead of writing y to the -6 there, I'm going to write over y to the +6th power. Okay? Did you multiply them and went 8?
No, I just have to.
Oh, okay. Yeah, when you move it to the other side of the fraction bar, then it changes the sign. Yeah. Just to keep showing you a variety of different ways to do these type of problems, I'm going to take this -3 and it's got to go into that exponent. It's got to go into that exponent. And 4 has an exponent of 1 on it. It's also got to go into that exponent. So if I do that, then I have 4 to the -3 power, m to the +6th power, because -2 times -3 is +6, and n to the -12th power.
So you just leave it as 4 to the.
No, because do I like negative exponents?
No, so you
No, so that's got to go downstairs, right?
with the n and the -12.
Yep. Okay. So then that would leave me on top. That would leave me with m to the 6th power on top, right? On the bottom, 4 times 4 times 4 is 4 times 4 is 16 times 4 is 64. Okay, so then that would be 64. Easy there, Siri. N to the 12th. Okay. On this one, on number 5 here, 8 and 12 here don't have any exponents on it, but they can still be reduced because the fraction 8 over 12, 8 can be divided by 4, 12 can be divided by 4. So that would end up being 2 over 3. Okay. C here now. Now if I'm looking at this, I don't like the -2 up there, so I'm going to put C to the +2 on the bottom then. Okay? And that would leave me with 3 C's on the bottom. In terms of D's, I've got 3 D's on the top and I've got 4 D's on the bottom. That means I've got 1 more D on the bottom, right? So that means I'm going to need a D down there. There you go. This exponent of 3 needs to go into negative 3 into 4 and into the 3 for the y. So negative 3 times negative 3 is positive 9, times negative 3 is negative 27, x to the 12th, all over y to the 9th.
Can you?
Yes, because it's not an exponent. It's just a number. Now, with scientific notation, you guys have probably all seen that somewhere along the line in a science class. You know, we're talking about something like 6.2 times 10 to the 24th. Isn't that a mole chemistry? Right? 23rd? Is it 23rd? Ah, here I thought it was going to be so. I thought Mr. Lemmert had taught me so well back in 1992 that I remembered it, that I did. Okay? All right, so that's scientific notation. A couple of things about scientific notation. First off, you can only have one digit left of the decimal point. So you might have to adjust the exponent accordingly. So what I mean by that is if you move the decimal point to the left, you add to the exponent. Conversely, if you move the decimal point to the right, you would subtract from the exponent. Okay? Because that digit has to be between 1 and 9. It can't be a 0. Okay? What I mean by that is, well, let me get the other rule in first. Okay? So then there's going to be two parts to your scientific notation. Okay? The first part is the number part. Okay? That's where this rule number 1 comes into play. 1 digit to the left, we got to move it and all that fun stuff. The second part is going to be times 10 to the certain power. And in scientific notation, that's the only time that we allow negative exponents. Okay? Because you can, small numbers would be like 10 to the negative 23rd power. So on and so forth. Okay? So, if we wanted to put 72,000 into scientific notation, the decimal point is right here, correct? I need 1 digit to the left of the decimal point. So I'm going to have to move this over 1, 2, 3, 4 times. So this would be 7.2 times 10 to the 4th, because I moved that decimal point over 4 times. Okay? Today, what we're going to have you do, or what I'm going to have you do, is I'm going to have you multiply and divide scientific notation type thing, type numbers. Okay? So what happens there is when you're multiplying and dividing scientific notation numbers is you multiply or divide the number part you add or subtract the exponent part, and then you've got to adjust so that you have one digit to the left, and so on and so forth. Okay? So these two parts. So if we're multiplying, you would multiply and you would add the exponents. If we're dividing, you would divide the number part and you would subtract the exponents. Okay? Let's put it to work. Okay? 6.8 times 10 to the second power times 3.6 times 10 to the 8th power. So the very first thing that I would do here is I would multiply these two numbers. Eight, carry the 4, 4D, 0, 4, carry the 2, 20, I get 8, 4, 2,448. Yes? But because it's point there, so it'd be 24.48. Yeah? Then what I'm going to do is I am going to add those two. With me so far? Okay? Now I've got to adjust it. So this, my final answer here would be 2.448 times 10 to the 11, because we had to move it over 1 to the left. Yep.
Okay, so now what would the long version of that be?
What do you mean?
Without the 10 to the 11.
So you would have 2448 and 8 zeros after it. Okay? You try the next two. So here in number 8, the first thing that I'm going to do is I'm going to divide those two numbers. 9.3 divided by 3.1 is 3. Then what I'm going to do is I'm going to subtract those two exponents. 16 minus 4 is 12. So we're left with 3 times 10 to the 12th. On this one, I would take 5.7 and I would multiply it by 210.8, and I'm going to cheat and I'm going to say that that is 1,201.56. And then I'm going to take these two numbers and I'm going to add them 46 plus 18 is 64. But now I can only have one digit, so I'm going to have to move that over 3 times. So my final answer here would be 1.20156 times 10 to the 67th power. Very big. Yeah. Again, I remind you to please bring your Chromebook. And earbuds or headphones or whatever it is you use on Thursday. Tan is the color of the homework this week, and right now you can do the last 2, numbers 15 and 16 are the ones that you can do from today. Okay?